Hi everybody, this is Alex. I'm a tutor here at Chegg in statistics, biology, and chemistry. Today we're going to talk about histograms. So here's an example of a histogram. The first thing to note is there is no vertical axis. And you notice each of these, we call these bins here. So that's a bin. This 7 to 10 here is also a bin. All of these bins have a little block above them, and this block has an area. That area is proportional to the percent of the sample that this histogram represents that falls within that bin. So this 15 to 25 bin, the square above that bin represents the percent of data points that fall in the 15 to 25 range. Histograms are really useful. Statisticians use them to represent really large sets of data, and you can get a lot of useful information out of them. So let's start by sketching out and building a histogram. So let's see, we'll go over here. So what I've done here is I'm just summing up ACT scores from a class of 50 students. So what I would have done is I would have collected a list of the scores. So I'd have had 3, 8, 26, 21, so on and so forth. And then I am going to put those into bins. So these bins, I have 0 to 4, 5 to 9, 10 to 14. So what I'm going to do is I'm going to take all the scores and I'm going to count how many fall between 0 and 4. There's one student that got between a 0 and a 4 on the ACT, so I put a 1 for that bin. So let's start off by drawing this. So we'll call that 1. And then for between 5 and 9, there were 3, so that's triple of 1, so I'm just going to go 3 times as high. So about there. And then 10 to 14, there's 4. So a little bit higher. It might have been a little higher. That's okay though. And then 15 to 20. So we have 7 here, so that's about 3 more. So I'm going to go up here. 20 to 25, we have 11. So here we're going to go another maybe 4. So it's going to go. Sorry for cutting that off. That's okay though. And then this next one is 15. So we're going to go even higher. And then we're going back down to 5, so we said that this is 1, this is 3, this is 4, so we'll go a little bit higher than that. And then we have a smaller width of bin, but that's okay, and there's 4 in there, so it's back down here. Alright, so we just made a histogram. Great. Alright, now we're going to look at a histogram and try to take measurements and interpret it. So here's a histogram, and let's just say this represents the number of baskets a player makes on average in a NBA season. So what I've done here is we take a bunch of data from a bunch of players in the NBA, and for each of those players we average the number of baskets they successfully make per game, and that average number of baskets per game is what's plotted in this histogram, just like we did before with that sketch. So then we can ask questions. So were there more players making an average of 5 baskets per game or 15 baskets per game? So this is a pretty simple question. We really just have to look at the heights, but keep in mind when we're dealing with histograms we want to look at areas. So you can't make 5.5 baskets, so what we'll say is it's between 5 and 6 baskets, and then 15 and 16 baskets. So between 5 and 6 we have a height of up here, and then 15 to 16 we have a height of about half of that. So there's more players making an average of 5 baskets per game than 15, and it's about double. Next question: was it more common or more frequent for a player to score 10 to 15 or 15 to 25 baskets per game. So now we're looking a little bit more closely at the widths of these bins. So for the 10 to 15 range, we have this bin here, right? So for 10 to 15, we have 15 minus 10. So we have a bin size of 5. And then the height, let's just arbitrarily say that it's 2. I know we have a little kind of small difference up here, but since we're just doing really rough measurements, let's just say that this line and that's all the same height there. So we'll say that that's a height of, in this case, 2, just for calculations. So height is 2. So we just calculated the first area. And what's 5 times 2? 10. So now let's look at the 15 to 25 range. So that is a width of 10. 25 minus 15. Minus 15. That is 10. And the height is about half of this first one, which you said was 2, so we'll call it 1. 10 times 1 is 10. So for this question, the answer is actually both are just as common. It's just as common for a player to make 10 to 15 baskets per game as it is for 15 to 25 overall in the NBA. All right, next question. Here, I'm gonna erase these a little bit so we have more room. All right, so for what's this, 3A. So right now what we've done is we've called this area over here, this is 1%. So this area there is 1%. So from 0 to 1, it's 1%. So we can ask the question, what percent of players scored between 0 and 5 points on average per game? So we already know from 0 to 1 is 1. But then from 1 to 2, what is it? So this area it looks like it's about twice as high as the 0 to 1 bin, and it's the same width. So we'll just say it's 2. 2%. And then from the 2 to 3 range, it looks like it's about another 1, so we'll say it's 3. So we have 0 to 1, 1 to 2, 2 to 3, and then 3 to 4. Looks like it's about 4. And then the next one looks like it's about 5. And then it looks like the next one... Oh, and sorry, that's it. So what we have then... Sorry. This is going to total to about 15. And all these bin widths are 1. So we have 0 to 1, 1 to 2, 2 to 3, 3 to 4, and 4 to 5. So for the question, what percent of players scored between 0 and 5 points on average per game? The answer is 15. So 15%. All right, 3B. What percent scored 25 to 50 baskets per game? So right now we're looking at this bin here. So the width is 50 minus 25, and that's 25. And the height looks like it's about half of the 0 to 1 bin. So we'll say it's 0.5. And we know the height of 0 to 1 is 1 because the width of 0 to 1 is 1. The area is 1%. Therefore, the height is 1% divided by 1. So it's 1. So now we're going to call it 0.5. 0.5. And that is 12.5. So 12.5% of the data is in this 25 to 50 bin. So 12.5% of players make an average number of baskets of between 12 and 50 per game. Might be a little high. It's okay. So this last question is dealing with the term median. So the median is where 50% of the data lies to the left and to the right of that point. So in this case, it means we're dealing with areas. So we're 50% of the area, so total of 0.5, because all these areas have to add up to 1. 50% is on the left, 50% is on the right. So what we'll do then is we can start with 15. So we know 0 to 5 is 15. 15%. And then 5 to 10, it looks like the height is about the same as that last one. So the height's about 5. This 5 here, so the 4 to 5, we saw 5. So 5 to 10 is about 5. And the width of 5 to 10 is 10 minus 5 is 5. So we have 15 plus 25, and that is 40. So we need 10% more. So where do we get that? So we're going to get that from the 10 to 15 bin. The 10 to 15 bin has about the same height as the 5 to 10 bin. So it has a height of 5, and we need 10 more, so we need a width of 2 more. So how do we get a width of 2? Well, 10 to 12, so 12 minus 10 is 2. So we'll do 40 plus the height of 5 times the width of 2, so 12 minus 10 is 2, and that gives us 50. Ooh, sorry. So from that, we know that the median number of baskets per game for players in the NBA, on average, is 12. This is not real data. It's made up, but there you go, 12. So I hope you learned something about histograms today, and histograms are a little bit more clear. I hope that next time you see a histogram, you'll be able to make inferences about the sample and the population using the histogram, and just doing some basic arithmetic to get really powerful information. Thank you.